Hey guys, welcome back to our math class. This is Miss Reynolds. So today we're going to be talking about Polya's 4 steps to problem solving. Here on the screen, you can see those 4 steps laid out in front of you. So the first one we have understand the problem, and then we're going to make our plan. We'll carry out that plan, and then we'll look back at our solution. So just to go a little more in depth into each of these steps, I have some information for us here. So with the first step, understanding the problem, we need to identify what's being asked, and it's a good idea to restate the problem in your own words. That means that we need to identify the parts of the problem that we know, which are the givens. We need to identify parts of the problem that we need to find, which are the unknowns, and then we need to identify and potentially disregard unnecessary details of the problem. With word problems, it happens quite often where they add a lot of details that don't lead you to the solution. So those are details that we can absolutely just ignore. Moving on to making a plan. When we do make a plan, there's several ways to go about that. So we can identify how we're going to attempt to solve this problem by using things like making an equation, making diagrams, charts, or tables. We can work backwards, we can guess and check, we can look for patterns. There's other ways to do it as well. These are just a few. But it's a good idea to know what they're asking, and then from there, make a plan on how you are going to attempt to solve this problem. And when you choose a way that you're going to attempt to solve, that's when we carry it out. We try to carry out the plan, and we're going to use the method that we chose. And we're also going to show our work. It's important to show your work because when you get to step number 4, that's when we're going to be looking back at our solution. We're going to look back to assess if there's a better or more accurate way to solve. And also it's a good idea to look back and check our work. This is where we can plug in numbers and we can add the pieces back together to make sure that we did in fact get the right answer. So notice real quick before we move on that with this diagram in the 4 steps, it goes from understanding the problem to making a plan to carrying out the plan to looking back at the solution. And when we get to the end, notice how we can go back to any of the prior steps if necessary. This is important because we need to understand where we went wrong if we did. And also it's just a good idea to look back because we might have done it the most complicated way possible, and after the fact we could potentially identify an easier way to solve. So there's a lot of great reasons to follow this plan here when trying to solve math equations. Okay, so moving on to our first question. Notice here we have our Polya's 4 steps right on the side just in case we need to refer back to them, which we absolutely will. So with this word problem here, it reads, a large department store sold a significant number of footwear last year. 118,214 pairs of boots were sold, 37,092 more pairs of sandals than boots were sold, and 124,417 more pairs of sneakers than pairs of boots were sold. How many pairs of footwear were sold last year? So right offhand, this can feel a little overwhelming because they're throwing a lot of really big numbers at us. But that's okay. We can deal with it. We just have to organize our information. So with our first step, understanding the problem, we're going to lay out what we know. The givens here are that the boots are at a value of 118,000 and then some, of course. So we're just going to kind of round the numbers just for the sake of talking because it's just so much to say them all the time. So for the boots, we have the 118,000. And then in the second part of our equation that gives us some information, it talks about sandals. It says that there's 37,000 more pairs of sandals than of boots. But that tells me that boots, in comparison to sandals, in relation to sandals, is a base number that is included. So we have the number of boots, which is our 18,000, plus an additional 37,000 pairs of shoes, which were sandals. And that'll give us this sandal value. Moving on, we're going to do the same thing for the next part. It says 124,000 more pairs of sneakers than pairs of boots were sold. So again, it's using boots as a base number. That means that we're going to put boots here, but then we're also going to add the sneaker value they did provide, which is the 124,417. From there, we can identify that this is the information in the problem that they had given us already. But this very last question says how many pairs of footwear were sold last year. So the ultimate goal of this question is to find out the total number of shoes that were sold in the last year. So that's going to be the number of boots plus the number of sandals plus the number of sneakers, and that will give us our total pair of footwear that were sold last year. Moving on to making a plan. In this sense, Considering we already have all of our information, it would make sense to use a tape diagram. Here, I drew a rough sketch of what that may look like. We have our single value for boots, we have our sandals, which is boots plus the parts for sandals, and then we have sneakers, which represents the boots here, and then the additional number for sneakers. And that's exactly what we have here. Now we just have a sort of a visual component for it here. The next part, after we make our plan, we're going to carry out our plan. So in step number 3, we added our numbers and our tape diagram together. So now we have a more concise visual of what's going on here. With the boots, we have our 118,000 in our blue blocks. In our sandals, we know it's going to be our boot number plus our 37,000 more. With our sneakers, it's going to be our blue block for our boots with an additional 124,000 for our sneaker number. Now when we do the addition for all of this, because as we know, we need to add them all together to get our total number of boots, or our total number of footwear rather, for the entire year, we need to add them all together. So when you do that, for boots, we have our regular number for boots there. We have our sandals coming in at a value of 155,306. That's the number that you get when you add this part here to this part here. And then with our sneakers, we do the same. So when you add the value of boots plus the value of the additional sneakers, it gives us 242,631. So when you add all 3 of these values together, that gives us our grand total of 516,151 pairs of shoes that were sold last year. Moving on to step number 4, we can look back. So we saw our pattern where each option described had boots as a base. And then looking back at how we went to execute our plan, we saw that we used the tape diagram, and I think that the tape diagram was a great way to organize our information because it allowed us to concisely add. And that's how we use Polya's 4 steps in a problem regarding a tape diagram. So moving on to our next question. It reads, John is twice as old as his friend Tom. Tom is 5 years older than Allie. In 5 years, John will be 3 times the age of Allie. How old is Tom right now? So there's a lot of information going on here, but while it may seem overwhelming at first, as long as we follow Polya's 4 steps, we'll be able to dissect this problem and answer it. So in step number 1, we need to understand the problem. The first thing that really jumps out to me is the main question. How old is Tom right now? So how old is Tom? That's what the whole focus of this question is regarding. So Tom is our first unknown variable. So T for Tom, Tom's going to be X. That's his age. How old is Tom? Tom is X years old. We don't know yet. So from there, though, we have other information that we can add in relation to Tom. We know that John is twice as old as his friend Tom. So that means that J equals 2 times X, or 2X. So John is 2 times Tom's age. Tom is 5 years older than Allie. So here we have Allie equals Tom's age minus 5 years. We didn't write T equals X plus 5 because that leaves Allie out completely. That is an equation that doesn't actually relate to Allie. She's nowhere in that. So in order for it to relate directly to Allie, we need to take Allie and relate her to Tom. We know that Tom's age is X. Allie is 5 years younger than Tom, so Allie's age is going to be X minus 5. So now that we understand the basis of the problem, with the exclusion of this sentence here, which we will get to, we have all the other information right here in this first part where we understand the problem. Moving on, now we have to decide how we're going to make our plan. So with this problem, there's so much going on, it'd probably be best to make a table. We're working with 2 different time frames, which means there can be 2 different columns. We're working with the time frames of age right now and then age in 5 years. And there's 3 people involved, John, Tom, and Allie. So if we look at our table and set that up, it would be a 3 by 2, okay? So moving on, let's go ahead and carry out our plan. So first we need to fill in the given information. So we figured out that Tom's age equals X. We found out that John's age equals X times 2. And then Allie's age is X minus 5. So notice that these three parts of information here are the same as the parts of information here, but all of them are plus 5 because we're talking 5 years in the future. So John is going to be 2x plus 5 in 5 years. Tom will be x plus 5. And then also in 5 years, Allie will be x minus 5 plus 5. From there, we need to decipher the most difficult sentence in our problem. So it says, in 5 years, John will be 3 times Allie's age. We can add, or actually apply, we can apply numbers to all of these. We can apply values to all of these parts of the sentence here. So in 5 years, which is plus 5, John will be, let's look at it this way better. Okay, in 5 years, John, which is 2x, will be 3 times Allie's age. But notice here, Allie's age, we're talking about in 5 years from now, so Allie's age also has that plus 5 at the end. But when we take these components here and put them into a numerical sentence, we have 2x plus 5 equals 3 times x minus 5 plus 5. And now the only thing left to do is solve. So with solving, we have 2x plus 5 equals 3 x minus 5 plus 5. We do parentheses first, minus 5 plus 5, that cancels out. And then we distribute the 3 onto the x, and that's going to give us 3x. And so now our equation reads 2x plus 5 equals 3x. The next thing that we're going to do is we're going to subtract 2x from both sides. And when we do that, that's going to leave us with 5 equals x. We know that Tom is representative of x. That's what we were trying to find out. So x is the 5 that applies to Tom's age. Tom is 5 years old. So when we're looking back at our problem, I think that the way that we solved our problem was positively influenced by the creation of our table. There was a lot going on here, and it's a lot better to be able to visually see what's going on instead of trying to organize it in a different way. That was probably the most concise and best way to organize it. We can check our solutions by plugging in Tom's age back into the equations and comparing the other ages with their descriptions in the original problem. So this is a way that we're going to look back and make sure that we did in fact get the right answers. Okay, so we went ahead and took x equals 5. This is our chart. It's just not as organized as this one looks, but this is exactly the same thing. We have John, Tom, and Allie, and their ages now and their ages in 5 years, and we're going to plug x back into them. So John's age now was 2 times x, so that's 2 times 5, which means John is 10 years old right now. We know that x equals 5, so Tom is 5 years old right now. And then Allie was Tom's age, which was x minus 5. That means that she's 0 right now, meaning she's probably an infant, maybe a newborn. So in 5 years, though, we have some values to figure out as well. So it claimed that in 5 years, John will be 3 times the age of Allie. Let's check that to see if it's true. So John's age was 2x, so 2 times 5, and then plus 5 or 5 more years. That gives us a total of 15. Now looking at Allie's age was x minus 5, which is 5 minus 5, which is 0, plus 5 years, so 0 plus 5 equals 5. So does that match up? In 5 years, John will be 3 times the age of Allie. Well, Allie's age in 5 years will be 5. And John's age in 5 years will be 15. So yeah, that checks out because 5 times 3 equals 15. John will in fact be 15 years old, which is 3 times older than Allie's age of 5 years old in 5 years. So that's a good way to check back and see if your equations and your numbers have all come to be. I think that's about it there. So it looks pretty good. Looking at our chart here, it definitely qualifies our answer. And I think that the way that we went about solving it was precisely right. So with that all in mind, I'll go ahead and go back to this main screen here. Again, this was Polya's 4 steps to problem solving. We just solved 2 different equations using the 4 steps, and I hope that you found this helpful. Have a good day.